In Dasht-e, Iran, the ground temperature can reach 159 degrees Fahrenheit, hot enough to blister exposed skin in seconds, hot enough to melt the soles of your shoes to the sand. The air shimmers like liquid metal, yet there's no water, only a dry, suffocating glare that bends the horizon into mirages. For 25 years, parts of this desert haven't seen a single drop of rain. The ground has fractured into geometric scars, and thin salt crystals glitter where shallow lakes once lived centuries ago. Even the wind smells burnt, an acrid tang of scorched minerals and salt baked into the crust itself. This heat wasn't measured by thermometers stuck in the ground. It was captured by NASA's MODI sensor from orbit, detecting a single pixel on our planet glowing brighter than anywhere else on Earth. A thermal signature so intense it outshone the Sahara, the Outback, and Death Valley combined. Walk here, and your body begins to fail by degrees. Within minutes, your shoes soften, the rubber yielding to the crust beneath. Stones become untouchable. Metal tools warp and discolor. The wind lashes like fire from an open oven door. Breathing burns. Blinking burns. Even standing still becomes survival. But that's the strangest part of our nature. We are drawn to the absolute limits of existence. A cognitive dissonance scientists call the curiosity paradox. We feel compelled to look at the edge of the world, even if that edge is fire. Yet something survives here, something that shouldn't. Not plants, not animals, something older. A black crust creeping across the rocks, alive despite the heat that could sterilize surgical steel. Microbes, thriving in temperatures that would destroy every cell in your body. It's the first paradox of Dasht-e. Life doesn't just endure the heat, it needs it. But here's the question that matters. How long could a human survive here without water? Comment your guess below, because the answer might shock you. In the heart of Dasht-e lies a place locals call Gandom Beryan, the toasted wheat field. Here, the ground doesn't just burn, it breathes. Waves of superheated air rise from cracks in the basalt, bending light like a living mirage. The air itself shimmering, the heat so intense you can almost hear it crackle. The black basalt here isn't just rock, it's alive. What looks like volcanic crust is actually a biological mat. Millions of extremophile microbes spreading like skin across the stone. Under a microscope, they shimmer, each cell a fortress against heat that would sterilize surgical instruments. But here's what makes them truly alien. They don't just tolerate the heat, they need it to survive. Below 140 degrees Fahrenheit, a temperature that would still cook human flesh. These organisms begin dying, their enzymes collapsing without the energy surge only extreme heat provides. They've evolved proteins that fold correctly only when the environment is lethal to everything else on Earth. For them, fire isn't destruction, it's nourishment. Think of the human body. At 107 degrees Fahrenheit, your own proteins unravel. Your brain begins to fail. These microbes start thriving where human life ends. Each gust of wind carries invisible spores, life riding on currents of death itself. They carry 2 billion years of adaptation in microscopic form. Evolution compressed into proteins that thrive in temperatures that would melt your DNA in seconds. NASA scientists study them here not to learn how life survives extremes, but how extremes might create life. If these organisms require 159 degrees Fahrenheit to thrive in Iran, what temperatures might life require on Venus? Or on exoplanets orbiting red dwarf stars? The desert isn't empty. It's just empty of anything that looks like us. And here's the unsettling truth. If you try to cross Gandom Beryan on foot, these microbes would still be thriving in the dust cloud kicked up by your collapsing body. If even life survives this, what chance does a human have? If you walked into Gandom Beryan right now, your clock would start ticking. For hours. That's the longest a human body can endure here before collapse. This timeline isn't speculation. It's pieced together from Iranian rescue logs and extreme survival data. Hikers found with core temperatures exceeding 110 degrees Fahrenheit. Their shoes fused to the salt crust. Even with specialized NASA Mars analog cooling suits, researchers report core temperature spikes and suit failure within 45 minutes of sustained exposure. In the first 30 minutes, the heat feels theatrical, like standing beside an open oven. Sweat forms instantly, then vanishes before it can drip. You start to feel dry, not wet, because the air steals your moisture faster than your body can make it. By hour 1, your heart races to pump cooling blood to your skin. The vessels expand, pressure drops. Dizziness comes in quiet waves, whispering that you're no longer in control. By hour 2, every breath scalds. You stop sweating. Your body, confused, begins to boil itself from the inside. Internal temperature, 104 degree F, 105 degree F, 106 degrees Fahrenheit. The proteins that keep your cells alive are unraveling, exactly like those heat-proof microbes buried beneath your feet. By hour 3, your vision tunnels. The brain shrinks fractionally inside its skull, thought fragments into flashes of light. Some explorers describe this stage as euphoric, a cruel trick of the mind, the curiosity paradox again. You still want to see what's beyond the next dune, even as your body turns to dust. By hour 4, the system fails. The heart misfires. Consciousness narrows to a single, flickering thought. How much farther? In this place, even death takes effort, because there's nothing left to cool you down. At first, the desert silence feels absolute, the kind that hums. But spend enough time here, and that hum begins to change. Researchers and explorers report the same experience. Voices carried by the wind, whispers that seem to say their names. At 159 degrees Fahrenheit, sound travels differently. Heat distorts air density so dramatically that sound waves refract and fracture, creating acoustic mirages, echoes without origin. But the mystery deepens when we consider the landscape itself. In specific areas, the wind moves uniformly over the high, salt-laden dunes, creating a phenomenon known as the singing dunes. These aren't gentle sounds. They are deep, low-frequency vibrations, often over 100 decibels. The bass hum isn't a voice, but it acts on the human ear in ways that can induce anxiety, vertigo, and auditory hallucinations. Inside your skull, the heat does the rest. Dehydration thickens the blood, lowering oxygen to the brain. Auditory neurons misfire, and the mind begins to fill the void with meaning. It creates the voices it can't find. Survival and sanity start to diverge. One scientist described hearing a rhythmic tapping, like footsteps following him over the dunes. Another swore she heard a child crying, just beyond the next ridge. When she turned toward it, there was nothing but rippling air. They all heard it, something calling them deeper into the heat. What would you hear? This isn't madness. It's neuroscience. NASA sensory deprivation studies show the auditory cortex never rests. When deprived of real sound, it amplifies internal noise, blood flow, muscle tension, neural static, and interprets it as external voices. The brain, desperate for social connection, manufactures it from silence. But here's what makes it truly unsettling. Some people don't experience it as terror. They describe it as recognition. One photographer, returning to Gandom Beryan 5 times, says the voices aren't random. They're personal. His late father's laugh, a conversation with a friend he betrayed, regrets given sound. The desert doesn't create new voices. It amplifies the ones already inside you, the ones you've been avoiding. And for some, that's not a hallucination. That's honesty. This is why local guides carry a chilling belief. The desert doesn't just steal your water, it remembers the dead, and the whispers are those who never found their way out. But whether it's acoustic physics or psychological collapse, the voices always fade when you turn your attention back to the ground, back to the heat, back to the tiny, black crust beneath your feet. The real, thriving life that waits to teach a lesson even the whispers cannot drown out. Beneath the blistering surface of Gandom Beryan, life refuses to surrender. What looks like lifeless black crust is, in fact, a dense mat of thermophilic microbes. Millions of microscopic organisms perfectly engineered to survive where humans would perish. Touch the crust, and it's warm, brittle under your fingertips. Kick up the dust, and the tiny colonies glint black in the sun, shimmering like heat-forged metal. A faint sulfuric tang drifts on the air, a chemical whisper of metabolic fire. These organisms don't merely tolerate the heat, they need it. Below 140 degrees Fahrenheit, their enzymes falter, proteins misfold, and metabolic reactions collapse. For humans, a core temperature of 107 degrees Fahrenheit is lethal. For these microbes, that same heat is sustenance, fuel for life. Every photon absorbed, every molecule energized, is a triumph of biology over the impossible. NASA researchers studying these mats see them as mirrors of potential Martian life. Creatures evolved not for comfort, but for punishment. They are also a chilling analog for Venus's atmosphere, where life might exist in specialized cloud layers or beneath the scorching surface. If life is this tenacious on Earth, consuming fire as fuel, it rewrites the rules for habitability across the cosmos. Recent discoveries, like the Lithophylla diatoms and hypersaline pools, hint that the desert still holds untold secrets of extreme adaptation. The desert isn't barren. It's a crucible. Evolution compressed into protein folds, enzyme chains, and cellular fortresses thrives here, mocking the fragility of human flesh. These mats record 2 billion years of survival. Every reaction a testament to resilience at temperatures that would liquefy DNA. The mats prove that life doesn't obey human rules. It adapts to the universe's indifference. But here's the paradox that haunts scientists and explorers. If life thrives when indifferent, why do humans keep returning to the one place that proves our own weakness? Perhaps the answer isn't in surviving the heat. Perhaps it's in understanding why we can't stay away. We are drawn here, not because it is safe, but because it is brutally honest. Every step across molten crust, every inhale of suffocating heat, every whisper carried by the singing dunes, reveals a truth we rarely face. Our limits, our fears, and the fragile persistence of life itself. In that stillness, the desert speaks, not just in heat, but in vibration, in the acrid scent of scorched salt. It presses on your senses until you cannot ignore your own vulnerability. The air shimmers with energy you can feel on your skin. The ground radiates an intensity that would blister flesh in seconds, and even the silence hums with the memories of those who ventured too far. Beneath our failing bodies, life endures effortlessly. Black microbial mats cling to basalt, thriving at temperatures that would unravel human DNA in an instant. 2 billion years of evolution are compressed into proteins that fold perfectly only under fire, indifferent to our panic or observation. NASA studies these extremophiles as mirrors of potential Martian life, and even as analogs for Venus, where the surface itself is an inferno. Life doesn't obey our rules. It adapts to the universe's indifference. And yet, despite the danger, humans keep coming back. A NASA geobiologist who studied Gandom Beryan's thermophiles for 7 years says, "I've worked in Death Valley, Atacama, Antarctica, but this place, there's something about the purity of the heat. No distractions, just you and physics. It strips everything else away." A photographer who's returned 5 times reflects, "The first time, I came for the landscape. The second time, I came because I couldn't stop thinking about it. By the 5th time, I realized I wasn't photographing the desert. I was confronting something in myself I'd been avoiding." An Iranian guide from Shah adds, "Westerners ask why anyone would live near such a place. We ask, why fear what tells the truth? The desert doesn't lie about what you are." This is the curiosity paradox. We are fascinated by extremes we cannot conquer, and obsessed with witnessing truths our comfort cannot reveal. Perhaps the true lesson of Dasht-e isn't how long we survive, but why we keep returning to test ourselves against fire. And in that return, we glimpse something rare, the honesty of extremes. And maybe, if we are willing to face it, the honesty of ourselves.